Hello, good morning. My name is Marcos Folani, an IT specialist at Skills Hub Al Dhafra, United Arab Emirates. And I'm starting this video as an introduction to programming logic, algorithms, and the C language, C Sharp, and object-oriented programming. This video is intended for students who want to develop their programming skills, both for competitions like Emirates Skills, as well as to prepare for the job market. The first thing we need to know is to understand what software is. So, software is a set of instructions that we teach to what it needs to do to solve a problem. So the computer by itself doesn't know how to do it. We need to teach the computer through instructions it can understand, such as how to process data and solve problems. So software is a set of instructions that tells the computer what it needs to do to solve a problem. We have several examples, such as desktop applications, mobile apps, games, and systems in general. What is an algorithm? An algorithm is a step-by-step solution to a problem. That is, the steps that need to be followed for a problem to be solved. So we can effectively use algorithms in various different fields, not just in software development or computer programming, but also to carefully guide or comprehensively teach someone how to solve a particular problem. In this illustrative example presented here on the slide, I have an algorithm for making a delicious sandwich. So it's nothing more and nothing less than a recipe. If you follow it, you reach the final result, a sandwich. So the very first step there would be to carefully get a fresh piece of bread. Step 2, generously add some cheese and ham. Step 3, gently close the sandwich. And step 4, finally serve it. Another very interesting thing when we talk about algorithms is the topic of the flowchart. Flowcharts. It's a visual diagram that represents an algorithm. So it's a visual representation of an algorithm. It's easier to understand and to anticipate possible problems. So to make a flowchart, we have some geometric shapes that are used. These are the ones I'm showing here on the screen. So I have a symbol for start and end. I have a symbol for processing or actions. I have a symbol for display to show information on the screen. I have a symbol for inputting information. That is when the user will type some information into the program. And I also have a symbol for decisions. So if some condition is true, do something. If the condition is not true, do something else. And the arrows indicate the direction of the data. Here I have an example of using a flowchart. So in this example, it's an algorithm that adds two numbers. So here the first step is start. Every flowchart starts with start and ends with end. And the step-by-step process to be carefully followed is clearly indicated from top to bottom, precisely because of the directional arrows. Step 1 is displaying a message prominently on screen, telling the user to accurately enter the first number. Then, in the next step, it's the data input, where the user will type in this false number. Next step it asks the user to enter the second number. Then there's a new data input where the user enters this second number. Here comes the processing step where we calculate the total, indicating that the first number plus the second number will be stored. The value of the first number plus the value of the second number will be stored in the variable total. And here, the next step is the display of the calculated total, and then the algorithm ends. Here is another example of an algorithm. So calculate the total price. So in this example, we have the input of the price, the input of the quantity, the multiplication of the price by the quantity, and the display of the total. So for this particular example, I'm going to meticulously make the diagram here, a completely blank diagram. And I will primarily use various geometric shapes. So here I will carefully start the entire flowchart process right here. First thing I want is to display a message on screen for the user, telling them to enter the price. Right after that, I need the user to enter this data. So my very next logical step here is to ask the user for the exact quantity. Right after this, I will then proceed to read from the keyboard the exact quantity that has been entered. Now, I need to proceed with the processing step to accurately calculate the comprehensive total value. So here, within the processing section, I will clearly indicate that the total is precisely equal to what I currently have recorded in the price field, meticulously multiplied by what I currently have recorded in the quantity field. And to finish up this process, I need to display the total calculated value. And right after, we will then proceed to effectively end the program. I will use the very same starting symbol to completely finish the entire process. Here, it's very important to draw the flow arrows to indicate the data flow. Without this, the algorithm might be read incorrectly, leading to misinterpretation. So I started the algorithm. I displayed a message on screen for the user asking them to enter a price. I used the data input symbol to read the number from keyboard. I moved on to step 2, which is entering the quantity. I displayed a message on the screen asking the user to enter a quantity. I performed the keyboard read to capture a quantity from the keyboard. Step 3, multiply the price by the quantity. So I performed the process where the variable total receives the value of the price variable multiplied by the quantity variable. Right after that, it displays the total and finishes. So here I have a clear example of a flowchart. This flowchart illustrates the steps of this algorithm. Moving on, I mentioned that we stored the various values in specific variables, the price variable, the quantity variable, and the total variable. But what exactly are variables? Variables are designated memory spaces within the computer where we can store different types of data. They are memory spaces where we store data during program execution. So here we have some examples. The variable AGE receives the value 25. That is, the person's age is 25. And here in front of the variable's name, there's the data type that this variable can store. On the next line, I have a variable called name of the string type, and the content of this variable is jump. We have some naming conventions for variables. So variables need to have very meaningful names. And when someone reads the variable's name, they should immediately understand what will be stored in it. The variable needs to have a data type. In most programming languages, we need to identify and define the data type of this variable. Here are some rules. A variable name should only start with letters or with an underscore. We shouldn't start a variable name with numbers or symbols. So we can't use spaces or special characters in variable names. And the standard practice in some programming languages for naming variables is to consistently use a specific convention such as camel case. What is camel case? The first word starts with a lowercase letter, and if the variable name has more than one word, they are written together, and from the second word onward, the initial letter is uppercase. So down here, I have some examples. The variable int, total quantity. So the first word starts with a lowercase letter, but in this case, it should be uppercase. The initial letter of the second word is uppercase. The same thing happens down here. A variable product price is of type double. So first name product starts with a lowercase p, and second price starts with an uppercase P. So if there were more than two words, all the initials from the second word onward would be uppercase. Another one here, string, customer name, and also the Boolean value is available. These are examples of variables and variable names that are appropriate in the programming languages we will be using. There are some things we need to avoid regarding variable names. So there's a pattern called snake case where you type words separated by underscores. This pattern is not recommended for C#, the programming language we will be using. This other pattern here, where you use a dash, a hyphen between words, that is also not accepted. And another one where all the letters are uppercase is also not recommended, except for constant. So down here I have the naming convention used in the C# language where variables use camel case. Here's an example. Methods will see what methods, classes, and constants are. Coming up next. So methods and classes. They use Pascal case, which means all initials are uppercase. Like here, the method calculate total or the class product service using uppercase initials. And constants, those can use uppercase, which means all letters are capitalized. Moving on, the common data types in C Sharp here are some examples of the ones we'll use the most, though certainly not all of them. So we have integers, numbers without places. For example, 1, 2, 3, -1, -5, -10. Double is used for numbers with decimal places. For example, 1.5, 1.75, 7.9. String is for text and words. And Boolean for true or false. So these are the data types we'll use the most when working with the C# programming language. So what is a programming language? A programming language is a language. It's a way to communicate with the computer in a way that it understands and can convert into the language that the processor understands. So it's a language that serves as an interface for what the programmer wants to do. And in a way, the computer understands what needs to be done. So it's a tool to convert algorithms into computer code. We have examples of several programming languages, for instance, C#, Java, Python, and others. We will use C# in this course. And why use C#? C# is the language used in the World Skills Competition. It's a very popular and widely used language in the market. It's a very powerful, incredibly popular and highly versatile language. Many large and prominent companies use it. It's a modern, incredibly versatile programming language, fully and officially supported by Microsoft and the extensive .NET ecosystem. The .NET is essentially a comprehensive set of powerful tools designed to significantly speed up and greatly improve the overall quality of application development. And it's specifically designed for desktop computers, mobile phones, and various other digital devices. It has a large and active community, meaning there are many people and groups all around the world who program in this language. The advantage of this is that whenever a vulnerability arises, we can be sure that someone is actively working to fix it. Whenever a new technology comes up, someone is working to bring these advancements so that we can use them. So the community also helps a lot in solving questions. Therefore, the more people working with this language, the more research material is available to you. Microsoft support is important as it ensures that the language will always be up to date. Also, the capabilities of .NET, so we can develop programs for mobile, for Android, for iPhone, for desktop, for web, and many other things. Let's start the programming logic section by running programs. It'd be in terminal mode, so still without an interface. It'd be lines of code. And this is a very interesting and effective way to turn complex algorithms into executable code and then have them efficiently and reliably execute by showing the entire process of input, processing, and output of data. I believe it's a cool way to learn about programming logic. For this particular task, I will be using the Visual Studio program. Visual Studio is a comprehensive and powerful integrated development environment from Microsoft, a leading technology company. Within this versatile environment, you can efficiently create a wide array of software solutions, including robust console programs, sophisticated desktop applications, dynamic websites, powerful APIs, and numerous other innovative projects. In this particular instance, I'm going to proceed with creating a new console application. I will now carefully enter a suitable name for it here. For this specific project, the chosen name will be KeyShop. I'll keep the .NET version 8.0 here. Ideally, you should always use the latest long-term support version. When you create the first project, it already comes up for us here. The first command, a comment, and a first command on the screen. I'm going to delete the comment and run first program to see what happens. Up here at top of screen, in center, I have a run button, green button. So if I click this button, this code would be compiled and it will be executed in a terminal window. So this code just writes a line with the text hello world. So here we can see the text hello world was displayed in terminal. Now I really want to do something. Now I want to do the execution of other programs right here. I want to read a user's name and then display on the screen a welcoming message along with the specific name that was just entered. So I will effectively use the console write line command to display a message on the screen and the console read line command to read input directly from the keyboard. To read a string from the keyboard, so here in this first example, I will create a variable of type string called name, and I will use the console read line command to read a string from the keyboard input. And I will then proceed to use the console write line command to effectively display the specific message welcome directly on the screen, and the specific name that was carefully typed on the keyboard. So here I currently have two distinct lines of code, and let's thoroughly test the actual results. Here it's waiting for me to type something, so I'll type my name, and on the second line the welcome message appeared and my name. So the computer did exactly what I programmed it to do. Now, a new example. I will use a variable double to store a number with decimal places. The name of the variable will be Crystal, and to perform this particular input operation, besides utilizing the console readline command, and in addition to the console readline command, I will definitely need something else. Why is this the case? Because here, the console readline method only reads strings. And in this specific context, it does not allow me to directly and easily convert the string value to a double precision floating point number. This is a crucial limitation that needs to be addressed for proper data handling. So I will use a conversion method where I specify the data type and use the parse method. And then I will take the string that was entered here, convert it to the double type, and store it in the variable price. So by doing this, I can read a string, convert it to the appropriate data type, and store it in variable of that type. Now, the next step, I want to read a quantity. So I will create an integer variable called quantity, and I will use the same logic. I will convert to an integer the string that is read by the console read line. So in this example, I already have the input of 2 pieces of information. And now I would proceed to the processing, which is the precise calculation of the total amount, which is exactly equal to the product of the price multiplied by the quantity of items, is essential. Okay, I already have data input processing, and now I just need data output. For data outputs, I will use the control write line and display the contents inside my total variable. So running this program now, it should ask me to enter 2 values. It will calculate the total value by multiplying price and quantity and display total value on the screen. Here, the first value I will enter is the price. So I will type 1.33, and the second value is the quantity. I'll enter 2. So it gave me the answer here. So 1.33, the price 2, quantity, the total value is 2.66. All right then. So that's the quantity we're looking at. Now we have another type of condition, specific structure, which is commonly called a conditional structure, or alternatively a conditional statement. In this particular example, I'm going to read an age value, so specifically an integer age equals convert to integer what is read from the keyboard. And with this age, I want to check if it is greater than or equal to 18. If it is greater than or equal to 18, I want to display on the screen the message that you can get a driver's license. If not, I will display that you cannot get a driver's license. So, if command is used to create a conditional structure, inside the if statement, we carefully place the specific condition that absolutely must be evaluated as true. So in this particular case, I want to thoroughly check if the person's current age is indeed greater than or precisely equal to 18 years old. And if this precise condition, which is clearly specified here, is found to be true, then it will proceed to execute the statement can get license. And there's also the else command, which is specifically designed for the opposite case. If the condition is not true, what exactly will be displayed on the screen? So in this particular example, when I run the program and then enter an age, for instance, 5 years old, it clearly shows me that you cannot yet obtain a license. However, if I run it again and enter an age that is above 18, it will then give me the message that you can already get a driver's license. Let's go. Next example. In the very next example, I specifically want to handle the process of reading a particular student's academic grade. So here, an integer variable inquiry equals converting to an integer the data that is carefully read from the keyboard. I am now going to start an if statement and then proceed to make a precise comparison. Is it greater than 7? This particular student is indeed approved. Here, I'm going to make one more, another detailed comparison. Else, if, that is to say, if the student does not have a grade that's higher than 7, I will then perform another comprehensive check to ascertain if their current grade is indeed less than 4. If the student's grade is found to be less than 4, I will then proceed to display the specific message. He has definitively failed. And in the last case, if the grade is neither greater than 7 nor less than 4, in other words, the grade is between 4 and 7, I'm going to use else as the equivalent of otherwise. So in this particular case, I will absolutely display that the student needs to retake a crucial test. Alright, so here I created a variable called grade. I converted the value read from the keyboard to an integer. I did the first comparison with if, checking if the grade variable is greater than 7. If it's greater than 7, it displays approved on the screen. Otherwise, I do another check to see if the grade is less than 4. If it's less than 4, I display on screen that the student failed. Otherwise, if the grade is between 7 and 4, the student can retake one test. Now let's test entering the first value as 2 here. It shows the student failed. Entering a specific value of 5 clearly shows that the student is indeed able to retake one of the available tests, and entering a distinct value of 9 definitively shows that the student has successfully passed. So here we effectively finish the initial part about conditions. In the repetition section, I'm going to show 3 commands: while, for, and for each. The while command has a condition, and as long as that condition is true, it keeps executing the program. The for command starts by initializing a variable. It can start here with any value. In the middle, there's stopping condition, and the third parameter is the increment. So in this example, a variable I start at 1, and it runs as long as it is less than or equal to 5. With each execution, the variable I increases by 1, incrementing. The for each command, which goes through a collection of items, executing the code item by item. So now I'm going to show the implementation of each of these types. So first, let's consider the while loop example. Here, in this case, the variable I starts at 0, and as long as the value of I is less than 3, I want to display the content or the value of the variable I on the screen. And with each execution, I want the value of the variable I to increase by 1. So running this code, here we see the first execution. I was 0, it went through. 0 is less than 3, it executed and displayed on screen. I++, I became 1. It executed again. 1 was less than 3, so it entered this line displaying I with the value 1. It reached the increment, added 1, and I became 2. It ran again, so that 2 is less than 3. So it executed the next line and displayed the value 2. And now I became 3. So in this case, when it checked the if condition again, 3 is no longer less than 3. 3 is equal to 3. So in this case, it exits and ends the program. That's precisely why it was executed from 0 to 2. Now, let's consider a practical example using the for statement to effectively create a loop. So, the for statement is utilized as follows. For int I equals 0, it will run as long as I is less than 3, and with each iteration I will be incremented by 1. I will be incremented, and every time this loop runs, I want to display the value of I. So here I have a somewhat different code, but its overall execution is precisely the same. Therefore, at the very start, the variable I had the numerical value of 0. The condition I less than 3 was true, because 0 was less than 3. And at the end of the execution, I is incremented by 1. So inside the execution, it displayed the value of I as 0. It executed. I became 1 because of the increment. 1 is still less than 3. It showed the value 1, incremented ran. I became 2, which was still less, and then displayed the number 2 on the screen. On the next iteration, when I became 3, it reached the condition where 3 is less than 3, and since that's false, it did not execute again. So, despite different code, the result was the same. And now, another example of a conditional structure, the for each. So, in this example, I'm going to create a variable of type list, a list of strings, AST, a string, a list of fruit strings, and inside it I'll instantiate strings with the following content. First item, apple. Second item, banana. Third item, cherry. And now I am going to proceed and use the for each command to run through the entire list of fruits. And for each individual fruit, I want to display its name right here, clearly. So considering fruit within the list of fruits, with each execution, the content here will be one of the items from the list. So in this example, I'm going to run it, and the expected result is with each execution, it takes one of the items from the list. There are items in the list. Okay.